So you buy a vacuum cleaner for your house. Give me an idea of how you estimate the duty cycle. How often you use the vacuum?
How long?
Divided by?
How long for one time?
How long until?
Warranty goes out.
Not the warranty. Until you use it again, right? Repetitions. So let's say I use the vacuum for vacuum my car 2 hours, and then the next time I use it again is next weekend. So I vacuum my car every weekend, let's say, for 2 hours. What would be the duty cycle? 2 hours divided by?
24 times 7.
Right, the unit must be the same. Hours divided by hours. So you cannot do 2 hours divided by 7 days. Okay? So you have to divide hour with hour. So 2 hours divided by 24 hours times 7, which is the number of hours in that week. So if you think about the difference between buying a cheap vacuum cleaner versus an industrial vacuum cleaner, oftentimes, for the same spec, the commercial vacuum cleaner will be like twice the price. What's the difference? Duty cycle. That's what you pay for. When you buy something industrial or commercial, you know, washing machines, right? Residential washing machines versus the commercial, like the commercial laundries. The price can be like literally 5 times price. What's the difference? The commercial ones can run up to 100 duty cycle, 100% duty cycle, meaning it's on all the time, 24 hours, 7, round the clock, 7 days a week, 365 days a year. That's what 100% duty cycle means. If you buy a residential washing machine and run it like that, it's going to break in like 3 months, literally. Okay, it's just not designed to do that. It's designed for washing your clothes once every 2 days, right? Or once a day at most. And that's it, right? You run 30 minutes in 24 hours. Okay? So the concept of duty cycle is very important. As engineers, you will select your machines or motors based on this.
Cycle times determine the life of a linear motion control system. The repetitive motion of back and forth, or up and down movements, produces friction, and this friction creates wear and tear on the system components. This cycle time, or duty cycle, is critical criteria in determining the operating life on just how long you want your system's investment to last.
Okay? There is another concept that is very crucial in machine maintenance. Have you ever heard this term? MTBF. Mean time between failures. So that means how often will your machine break down? How is this related to maintenance? Right. You want to maintain your machine before it fails. So if you take an average time, let's say your linear systems MTBF is like 20,000 hours. So at 15,000 hours, you want to take it apart, lubricate everything, check the motors, the carbon brush, whatever maintenance item there is, you want to replace it before it fails. Because downtimes are extremely expensive for a factory. Well, especially in developed countries. I mean, maybe not in Indonesia, but in modern countries, like you talk about $25 an hour. So if your machine is down for an hour, it costs you $25 per hour multiplied by the number of workers that is sitting there idle. So if you have 10 workers, that's $250 per hour of maintenance. So you want to do that before it fails. It's called preventive maintenance.
Accuracy and repeatability are one of the most considered overall for the system, in which may deliver the desired quality or precision required in the system or manufactured end product. If the application, for example, is for an automated pick-and-place machine, high repeatability and accuracy are most likely required. Typically, the accuracy of a ball screw linear actuator is 0.16 millimeters per meter with repeatability of plus or minus 0.01.
So that's pretty accurate. The ball screws are the most accurate. You're talking about 10 microns of repeatability here.
Millimeters. For belt drive actuators, the accuracy is around 0.5 millimeters per meter.
So obviously, what causes this less accurate systems? What is the difference between the belt and the ball screw? What is the source of the error with belt drive systems? Flexibility on the belt.
Kalau misalnya saya when like the machine design saya have like the one the one that
Right, it's called backlash.
Yeah.
Okay, there is some play between the belt tooth and the gear, right?
Yeah.
So those backlash also contributes to this. Now that's why you try to put some tension on the belt so it reduces that backlash, but still there is still some.
With repeatability of plus or minus 0.10 millimeters. Other considerations are whether to use limit switches or feedback devices, such as potentiometers and encoders for positioning purposes.
That's your servo right there.
There are many linear type actuators to choose from,
So because of the high price of the controller, if you buy a 10-watt motor versus a 100-watt motor for servo, the difference is basically none. So the 10-watt motor servo will be about 10 million, and the 100 watts will be like 11 million. So it's not like 10 times the price. The price is not by the motor size, because the brain basically is the most expensive part of the system.
as, for example, screw actuators and belt actuators. Screw actuators include lead screw actuators, ball screw actuator, and planetary roller actuators. Lead screw actuators having a threaded nut that moves with a screw. Screw-driven positioning systems are used in applications where accuracy and repeatability are more critical. These positioning tables use either an Acme or ball screw as the drive mechanism. Bearings are used to carry the load of the application. Lead screw solutions provide both simple construction and lowest cost. Many electromechanical designs incorporate a lead screw and lead nut, while some use a ball screw and ball nut. In either case, the screw may be connected to a motor either directly or through a series of gears. To rotate the nut,
So
through.
I think this is more toward machine design, but you gotta understand how to select these things. Okay, let's look at some examples here. So this is again sometimes it's called a Cartesian system. Cartesian as in like X, Y, Z. Okay, so you got this actuator, this one, and the Z. This is another version of linear actuator.
How to use them, how to drive them, and how to pick them based on the various specs for your application. So let's get started. Stop this from moving, but they are relatively slow. And I will get into that a little bit later, but the speed. So zippier, and then we can reverse it. and it will go the opposite direction.
Now, these linear positioning systems are the slower version, but they are more accurate. The composition is different than what we've seen before. You got the motor here, and you can guess what's inside. What do you guess? Your gears, right? Some reduction maybe. Okay, now guess what is here? A lead screw, right? But this time, the lead screw is not stationary. The lead screw is the one that is moving. Okay? So what happens is basically a sliding shaft that you can control the position of. So this is also practical for adjusting very tiny adjustments, because one rotation here might be only like 1 millimeter or less. So we're talking of very small adjustments, but the torque multiplication is also significant. So it's almost like a donkra. It's almost like a jet, if you think about it. So very slow, lots of force, lots of torque.
So it's really that simple, and you can use a motor controller. The main side, so I'm going to take this off, take this shell off, and then we can actually see the gears that are driven by the motor.
So you got bevel gear situation also here?
Correctly. But this is, I want to say maybe probably a 5-turn or 10-turn potentiometer, and it spins directly with the output shaft, and that gives you the feedback that ends up going on these main wires.
So you got the feedback also, okay? So this is the inside.
Now this one does not appear to have adjustable end of travel. So basically as this comes down, it will hit against there, and as it goes out to this side, it will hit against there.
So what's this for? Limit switches? What's the purpose of it? It prevents over travel, right? I mean, you're gonna destroy the whole thing if you keep going. So limit switches at the end, and this piece is going up and down the lead screw, okay? And you rotate that lead screw.
So it's just this little nub, or this little piece right there, that travels up and down and is hitting your end stop. So pretty cool.
So this thing does not rotate because the sleeve here is actually have a flat spot, so it cannot rotate. What it happens is it's going to go back and forth.
Some of the higher end ones actually do have adjustments, so you can kind of slide these along and you can have different end stops. However, this one does not have that, so you would need to rely on software to do that. And if you do use something like the RoboClaw, which I misplaced, if you use something like this RoboClaw, you can actually put that into the software use, and typically they have a very short stroke and they are very, very slow. So there's a lot of caveats to getting them free out of a wheelchair or really inexpensive out of it.
Okay, so
Hey guys, I'm Kyle, and this is Jason. So let's say you want to run this on an application like a dump bed on a UTV, and you want to run that off of a switch. That'd be pretty simple to do as well. All you need to do is supply power to the switch and wire the actuator in. And what you're going to need is a dual pole, dual throw switch, log input into your project, and then your program can know where it is within the stroke. All right, so I'm going to start at the top here and go ahead and take the cover off, which is...
Okay, we saw this. All right. So now let's look at some more advanced technology.
Yaskawa linear motion. TW balanced iron core. Yaskawa linear motors deliver. Yaskawa Sigma Track featuring FW series linear or for use in coordinated motion applications. Faster cycle times are the common result. Speeds up to 5 meters per second and acceleration up to 5 Gs are possible.
So this is a situation where you coordinate between a servo on the bottom and then an XY systems on the top, and it can follow the whole. I mean, obviously it's a demonstration, but you see how control systems are the core of this technology.
Here, a ball screw assembly and SigmaTrack execute the same point-to-point repeatable machine cycle. SigmaTrack enjoys an obvious speed and acceleration advantage over the ball screw system. In this particular configuration, every time the ball screw completes 2 machine cycles, the SigmaTrack has completed 3.
This one is called linear motor, so it's actually kind of a similar principle as in the elevated high-speed train. So you actually drive it using a series of coils rather than relying on the mechanical. So you're not limited mechanically.
Cycles in less than 11 months' time, depending on production requirement.
Okay, so that's an alternative linear motion control.
It was developed to improve performance from the traditional round motor with ball screws. Flat motors produce no backlash or reversal errors, providing better quality parts and surface finish. There are no...
So this is called a linear motor. Okay, it's like a motor, but you open it up. Right? Think about a motor, a cylinder with all the magnets around. Then now you open it and it becomes a track.
moving parts to wear, which not only increases a machine's lifespan, but also reduces its downtime for maintenance. A flat motor delivers improved cycle times and is capable of higher accelerations and velocity, whilst eradicating pitch errors. Another advantage of non-contacting parts is that no lubrication is required.
No lubrication, it floats.
Therefore, fewer consumables need to be purchased and contamination of the coolant oil is eliminated. Progressing into the tubular motor design helps improve machine life and wear on guideways or rails. It eliminates the downforce associated with flat motors due to the zero net attractive forces.
So if you wrap it around a rod, you can also go forward and back like that. No contact.
Because the magnets are contained within the stainless steel cylinder, machine builders can align the motor easier than before, allowing machines to be built faster and safer. By using the magnet's full surface area, the magnetic flux density is increased. The cylindrical design improves thermal contact, allowing for more efficient cooling. There is also no back iron, further reducing cogging and resulting in a smoother motor and superior surface finish. Anchor Motion has refined the tubular motor design, except the Linux design allows the motor to connect to the machine's current cooling system, requiring no additional cooling unit, improving floor space and reducing system costs.
These magnets do become hot though.
The lateral mounting cartridge design allows easy re-engineering, from a ball screw motor machine to a linear motor. The Linux linear motor can be used with any servo drive, or when connected to Anchor Motion's AMD 5X, enables it.
Alright, so pretty fancy. So you need to keep things around it. So very high velocity. Can be plenty powerful too. Only one downside. You guessed it.
You have so many magnets.
The control is also
If they're close loop, right?
the expensive one. Yep. You wanna play, you gotta pay.
It's good for like high temperature.
Today, I would like to share another video featuring the Rotary pneumatic.
Now, this is an interesting system because, see, with pneumatic systems, you either go all the way to the end and all the way to the other end, right? You cannot stop in the middle with pneumatic cylinders. But this control system is trying to stop it halfway. So it's like a linear drive with pneumatics.
Electro-pneumatic positioning system. The
Combination of
EPS.
electro and pneumatic.
We have a 32 millimeter bore by 100 millimeter stroke PRA cylinder using our ED02 proportional pressure regulator.
So typically in a pneumatic cylinder, if you remember, there is a piston, right? You put in pressure here, it goes all the way. You put in the pressure here, it goes all the way. But you don't stop in the middle. Now, what if you put in pressure both ports, but then you kind of regulate how much air goes in, and you can also put in pressure here to kind of stop it. And so what you have is basically a linear motion systems, but you need some electronic controls to control the air going in and out. Okay? So it's electro-pneumatic. Not terribly accurate, but it might be good enough.
In the middle of the screen, we have a representative of our Rotary cylinder family, the RTCH3.
Okay, this one is also going back and forth at
in this
5
example,
points.
we're using our ED05 proportional pressure regulator. Finally, on the top left of your screen, we have another PRA cylinder, this time in a 63 millimeter bore.
Okay, so it's kind of, probably the price is kind of not as expensive as linear motors, not as cheap as just pneumatic systems, but you get somewhere in between. Okay? Here is another electro-pneumatic.
PCS2, Ruble indexing. Standard pneumatic positioning options, such as multiple position actuators, are great cost-effective choices for basic application. Feedback cylinder to create a closed-loop system for quick, accurate.
So this is what is called a proportional valve. A valve usually only opens and closes, but a proportional valve can kind of open the valve halfway and kind of controls how much it opens. That's called a proportional valve. So you can do it for hydraulics or pneumatics.
Payload positioning. On a technical level, when in operation, the SPCS2 valve receives a command signal and supplies enough air to extend the rod. The actuator sensor then sends feedback on the rod positioning, causing the valve to generate additional power until the feedback voltage equals the command voltage. This sends the electromagnetic voice coil to a further established position, generating multiple different load requirements.
So there's some software too, because obviously it's a mechatronics challenge basically, right? Okay, finally, here's another motor. Look at how fast it is.
Here you go, here's a great example of linear drive technology. You can see it's flying past me in the background there. That was going at 15 meters a second. So if you're looking for a machine tool that is fast and then accurate, this is where you're going to go, linear drives.
Do you look at how fast it is?
Here you go, here's a great example of linear drive technology. You can see it's flying past me in the back.
It's literally flying. Okay. Now it depends. I mean, if you put a load on it, then it's different. Obviously, if you put some weights on the moving jig, still, I mean, that's fast. Okay. Now, if you remember last week, I showed you the pick and place for the SMD PCB, right? You gotta be that fast, and so it's enabled by all these linear motors. All right. So let's do some in-class exercise. But let's take a break. So come back in 10 minutes. Or 15 is probably fine. We got plenty of time today.
It's pretty bad, don't think about it. Yeah. That's all I did to do. Got me here.
What?
Udah. Oh udah, gue lupa bawa cuma nih. Tapi punya gue udah. Oh ya udah, gue kirain lu lupa. Dijual dokumen aslinya Marco.
Oi.
Ekskrisi. Selamat di selamat.
Gue kira emang F apa sih?
Oh gitu.
What do you think? What did they do in the middle of the night when they were trying to visit the Oh. Collectors.
You don't know free will?
That's classic.
Yes. He jumps over a wall.
It's because this swaps your he got annoyed by that. This, and specifically this time, they let them move around. It's like it's explaining your. I get it. I completely get it.
Like the my older charger this so much that the end becomes kind of relaxed. Sama tuh. Terus dia sama tuh udah jadi welding. Iya makanya sampai hitam. Udah jadi spot welding tuh.
I just get annoyed. Alpha. Yeah, but it's still fun.
Ya, ini tadi upgrade slot harganya 40 gue udah upgrade slot. Jadi kita upgrade slot
It is the best plug in the
gue
world.
jadi tinggal di dunia sekarang.
There's a lot of the new K plug.
Udah
I mean, it's secure. But you can't turn off the direction, and it's grounding, like, and it's actually your view plug, like, it's like having the ground. Like, there's a reason why this is locked. There's no ground. No, it's not a ground. It can be the ground. But the reason this is for is that it pokes vertically and opens up the flaps in here, so that you know. Also, you can force it. So you can't force it. So when I force this inside the plug, jam something into the I would jam my car keys. Yeah. You can technically force it. Yeah, it's safe. It's way safe. And you can run way more cars. Bigger. You know, aman itu asli doang. Yang kalau heavy and heavy, kalau di asli beda platnya. But when we're using European CE,
ini juga.
the worst one is
Gue jadi nggak bisa dapat ini nih 10 gara-gara.
kira kau keras, ternyata kertas.
itemnya pindah lah. Kok gitu siapa?
To be fair,
masalahnya kakak dulu nggak ada yang kasih itu dong pada kakak yang
Apa pakai karena ada satu iya dari boxnya.
harus pertama bidding, yang bidding pertama itu terus dapat dari box, terus ada kartunya.
Ini lawan bot-bot. Hah? Lawan bot-bot. Ini orang abang ya. Ini jadi jauh-jauh dari ada banyak apa? Itu ini boleh mati sih. Kasih main dulu. Coba gini.
No. It's like when you yellow, so if you hold it rusty,
Ini harus sakit banget. Iya. Sakit banget. Emang ngaruh? Gak ngaruh. Pas kalau gua ngaruh ini. My dear, smart my dear.
Masalahnya yang biddingnya
Itu udah mau balik ke pasar.
I've been shocked by this.
Apa tuh bukan gue ya? Gue cuma nurutin permintaan aku. Coba tadi gue nggak tahu tuh kalau ini. Loh dia mau aja. Gue kira kayak keluar atau apa kan? Duitnya pasti. Dari 40-an di berapa? 7. Kalau orangnya masih kalah sama Epic. Oh iya kan ini Epic. Kalau ini ngapain balik ke negara lu Cina. Sama menang atau kalah dikit menang enggak?
Oh yang itu
menang enggak? Menang enggak?
That's the big that's also going to be back. That's just easy.
Turu.
Oh, it's live.
It's in the mall.
Was it for like yeah, for lightning.
I didn't know it was beli Malika minta kita cacat juga. Parah.
Oh, that's like 16. You're dead.
Okay, take that. Bakal deh kanan.
Hampir.
Udah buang satu. Masuk ini nih. Apanya 56 mau 55. Yang penting 56 terus lo upgrade slot juga. Kita kemarin di kesetrum kan pas itu admin. Mana ini? Ini? Nah, ini di elektro. Gimana setrum? Satisfied, Cok. Gampang. Wow, preface juga kan. Lolitanya nggak aja kan. Konsen kesetrum. Tangannya kebak. Jadi iya bang. Ngomong tangannya kobong. Oh, pas gosongnya ada tawa itu. Tangan itu yuk. Coba. Kok bisa sih? Kebaca.
Ya begitulah, source-nya tidak dimatiin tapi dia pegang.
Satu lagi dari fine.
Bisa gini-gini.
Apa sih? Bang, tanya.
Kemarin dia jadi kemarin.
Soalnya kita
cuma konsen
itu pun aku video sama gua lagi ngajarin tidur
konsen buat apa?
Iya, ini top dulu. Jangan kita
Gua sate ditaruhin tes pen nyala. Iya, Cok. Tes pen tawa. Jadi gini tawa atau tes pen.
Pokoknya bikin pakai para
Oh, iya, Cok.
sekarang gua ambil
Iya, mungkin memegang kamu. Ombak terus pegang. Jadi gini tuh.
tapi badan kita ada kapasitasnya nggak sih? Udah gini dulunya langsung.
Iya, Cok.
Kan ini bisa sedikit.
Aja dulu.
You have to lebih
Kontak itu
oh the contact here
isi lagi sama sama. Kayak seperti ikannya juga. Kalau masih diiris. Kemarin udah ya, nggak tahu kayak kalau itu nyalain pembayaran terus tinggal nggak ada indikatornya. Kalau kan kalau kayak sini baik banget tuh. Aku di Jogja nih, Ciwi ya. Ayo lah, working kemen kemen. Lagi dorong dikit dia. Ya, besok. Apa tuh?
that works okay
I guess it's only this is Kemen tuh. Kemen. Yang kalau itu ini tidak mainan administratif cari lah baik apa kata pacar banknya. Kalau orang minyak dulu kan dari bom juga.
iya
Baru ini nggak sih Pak? Di balik papan kebakar tuh apa apinya?
and this is the public one yeah.
Ada. Tahun lalu. Ya nggak sih tahun lalu atau 2 tahun lalu ya? Ada. Ceritanya Bali. Ini bisa berapa? Lumayan. Tahun waktu belum terlalu lama sih. Papan banyak yang dibakar oh dibakar iPhone kan
respect bro
nggak tahu tapi yang mau bikin mau buat tempat ini belum lagi pas kerjanya itu lagi mau tes saya jadi oplos mau bikin lokal jadi dibakar mau mati
you have to give airtime
Okay, I posted an in-class activity in Google Classroom. So open up Google Classroom and look it up. Basically, I want you to do a survey. So study and compare between Rotary index tables, actuator options. So I want you to go out there and just browse through industrial catalogs. So I want you to actually download the catalog, study them, look at the different specs, what are the parameters or variables you have to select in order to pick one. Like you got the number of indexes, you got the speed, you got the cycle time, right? Study those. You got the numeric version, you got servo options. So tell me the plus and minuses between them. Features, price, which one is faster, more powerful. Explain also an example application where you would use the different types. Like say you're filling up this bottle, or you're assembling a phone, or a electrical appliances. Okay? So just explain an example application. If you find a YouTube video, sure you can attach it to. So I want you to do a survey and a study. And here another one for linear actuator. Okay? So rotary and linear. If you got any questions, just let me know.
factory? You mean like linear motor factory?
Linear rails with servo, lead screw, ball screw.
Yes, it's like sir.
Yeah.
Earlier, the catalog is like, is it for the example or was it like for the, it's for the example, right? The catalog of the,
Say it again.
so we need to give a catalog of the down, right, of the pneumatic rotary and the others.
Yes.
Is it like for our examples, is for our examples, right, for the product example that we're going to move?
Sure. Yeah. You gotta identify the part number that you will use and explain the specifications and why you select that one.
We need a video or picture, right?
Yeah, just put in picture. Why not? Axel, anything? Location is off campus.
Already connected to Wi-Fi, so.